Okay, we are now continuing with the same simple price elasticity model. Now I'm going to introduce the Monte Carlo simulation approach in the most rudimentary fashion using native Excel functions that are there. So we're not using any powerful applications. It's just what's already there in Excel. So we have the same model from before. So we have constant of 1000 and minus 1.2 for B sub 1, unit cost of 10, and then we have price is our decision variable. Then we have demand and the profit. Okay, and what we're going to now assume is that the price elasticity is not something which is certain. We cannot be certain that it will be minus 1.2, but it could vary, and let's assume that it will vary according to normal distribution. So we will later on we will discuss how to come up with probability distributions by analyzing data, and that will come later. But for right now, I just want to introduce the basic concepts. So let's assume that price elasticity would follow a normal distribution, okay, and the mean will be minus 1 and the standard deviation will be 0.05. So to define a normal distribution, we need to provide mean and standard deviation. So now we want to generate possible elasticity values for B sub 1 coming from this normal distribution. Okay. Later, when we in this module, we'll be looking at how to generate values from a given probability distribution. But for now, I'm going to just say how it is done, and we will look at more detailed analysis of how to set that up in the next in the next lesson. Okay. Now, the way we generate random values from a probability distribution, okay, from normal distribution in this case, is to provide, okay, if we use in Excel, there are normal functions, right? We have the norm.inv function, which actually gives the z value or the x value for a given probability. So you give it a probability, then it will tell you for that probability what will be the value in the normal distribution. So what we're going to do is we're going to provide a random probability value, which is given by rand and then the left and the right parenthesis. Okay. So the function rand gives you a number between 0 and 1. Okay. And any number between 0 and 1 can, it has any range of values has equally likely chance of getting selected. So it gives you a completely equal chance random number between 0 and 1. And since it is between 0 and 1, we can use it as a probability. So if this is the probability, rand left and right parenthesis, the number generated by the rand function, that's the probability, then we need to provide, okay, for that probability, okay, from which normal distribution, okay, you tell me what the mean is and tell me what the standard deviation is, then I'll give you the value from that normal distribution for this probability. Okay. So it gives you an elasticity drawn from a normal distribution with mean of minus 1 and standard deviation of 0.05. All right. So now this random function, okay, or any function will get recalculated when something happens in the spreadsheet. Like if you enter something, okay, anything. So what Excel does is, Excel by default will go and recalculate to some extent all the cells in the spreadsheet. So when I press enter, now you see the value changed because Excel went and recalculated all the cells, and when you recalculate rand, it's going to generate another random value, okay, and it's going to be different. So if I say delete here, again, that delete forced a calculation which made that value change. And there are ways of controlling this. Now, Excel offers some calculation options, how calculations are performed. So if you go to formulas, okay, calculation options, okay, so it's right now it's automatic. That's the reason why whenever you make any change anywhere, all the cells will get recalculated. So you can set that to manual. So if you set it to manual and then if you changed anything, so nothing will happen. You see, I have minus 1.077 and then it just stays there. It's minus 1.077 because nothing was recalculated as I made some changes. Now you can say calculate now, so that will recalculate all the cells in all the sheets, or you can do calculate sheet, which means it will calculate just that one sheet. So if I did calculate sheet, okay, so it does that. Now there is a third option which is automatic accept data tables, and that's given because usually it's the data tables that will take a lot of time to recalculate. So you may want to avoid having to do manual recalculations every time you make some change, okay, but you don't want to sit there and wait for the data table to finish recalculating every time you make small changes. So that's this option. So you will not recalculate data tables unless you do a force recalculation, but everything else will get automatically recalculated. Okay, I think it's a good idea. It's a good idea to leave it at automatic as far as our purposes are concerned. But when you set up large data tables, it's a good idea to set it to automatic except for data tables. Okay. So now we're going to perform replications. So that is, okay, when you randomly select a elasticity value from this normal distribution, that is just one trial. Okay, and it may not the confidence that you have in this being what the future elasticity will be is quite small, because it can be this or it can be anything else. There are so many possible values. So that is the reason why in Monte Carlo simulation what we can do is we can repeat the random choice or getting values from the normal distribution. You can repeat it, okay, 1 time, 2 times, 3 times, 4 times, 100 times, 1,000 times, 10,000 times, and then see what the output would be. And then when you repeat it hundreds or even thousands of times, then you will have thousands or tens of thousands of different elasticity values taken from the normal distribution, and that will reduce the variability, and you will have a better idea. You would have now considered many possible values for elasticity, and then it will converge into a nice output value for you. So how do we repeat this elasticity? How do you do the replications? Okay, and here is where the data table calculations that we talked about will be handy, because every time you make a change anywhere, it forces a recalculation, right? And so let's say that we want replications. Okay, how many replications we want? Say, let's say we want 1,000 replications, right? So I'm going to set up values going from 1 to through 1,000, and you can do that by doing shift and down arrow, so that highlights the entire column of A, and then you go on to fill series. You want to go from 1 to 1000. Okay, so now we have numbers going from 1 to 1000, and we want to look at the profit. Okay, this is going to be a data table, so we want to look at the profit, right? So now we will use this column as input. Okay, so now we're going to be like that, right? All right. Okay. So now the input values are replication numbers 1 through 1000. But that doesn't make any difference to the model itself. Okay. These numbers are not used in the model. This number is what is used in the model. But what we're going to do is we're going to run, we're going to set up a data table, okay, and we're going to use these as the input values and column input cell, okay. But this is not going into the model anywhere. All we want to do is to force a recalculation so the elasticity value will change for each replication number that we have. So we really don't need to put this into the model anywhere. So we can just say I'm going to insert it into a blank cell. Okay. Now by inserting the number into the blank cell, Excel is forced to do a recalculation, and a new B sub 1 number will be generated, and you will have a new profit corresponding to that elasticity value. So now if I click OK, so now I get the same value for profit everywhere. And the reason for that is we have set the calculation option to everything except data table. So the this is data table. So data table was not recalculated. So if you do calculate now, then it will change. Okay, let's format this to currency. Okay. And then we can find what the average profit is. Okay, and then we can say what is the standard deviation of sample stdev.s of that. Okay, standard deviation gives us an idea as to what the variability is, and we have the average of the profit for various values of elasticity. Okay, so now one more thing here, if you want to hide this first row, because our replication starts from here, this row is for the output of the data table. Okay, so either we can hide this row, in which case we need to move this up a little bit. Okay, so maybe if you take it up here, all right, so then we can hide this row. Okay, or we can, you don't want to hide it, then you can set the font color to white.